Okay, so as we build towards solving equations using these logarithms, it's useful to know their properties. Okay, and what I mean by properties is relationships between different types of logarithms and expressions with logarithms in them that allows us to rewrite them in useful ways. So you know a property for sure that you've used to solve a. There's an example, is the distributive property, right? So you've known this for a while now, you've seen this in action, right? So situations where distributing one term across parentheses is helpful, or you can also go the opposite, right? So we've also run into situations where factoring out this a and turning it back into a times b plus c was useful, okay? So the properties we're about to review are properties like the distributive property that allow us to manipulate logarithms. Okay. So these are our three properties that we're going to use in this lesson. So what this says, right, is if two things are being multiplied inside a log, that's the same as adding their logs together. Or if we're raising something to a power inside a log, that's the same as multiplying it by that power outside the log. And then notice this last property is just the opposite of the first one. These are kind of interchangeable, right? So if two things are being divided inside that log, what that looks like is them being subtracted. Their logs being subtracted, right? So we're going to use these three properties to simplify and expand some expressions involving logarithms. Okay, so here's an example. So we have log of x to the fifth times y. I want to fully expand it. So, and it says express the answer in terms of log x and log y. So the only thing that should be inside my logarithms when I'm done is just plain old x and y. We're going to do this in two steps. The first step is going to be my first property, right? So I'm going to say log x to the fifth plus log of y. Okay. So that's my first property. Log AB is equal to log of A plus log of B. Notice my exponent goes along with the base, so it goes along with the x. And then my next step, remember I want plain old x and not x to the fifth. So my next step is 5x plus log y. Log y didn't change. Okay, so that's a pretty easy example. We're going to do one more, and then we're going to do a really spicy one. So again, we're going to expand the logarithm fully and express the answer in terms of log x here. So here, remember 9x to the fifth is really 9 times x to the fifth. So I'm going to split that up actually to log of 9 plus log of x to the fifth. Okay, so I pulled that 9 out. And then just like before, I want to rewrite this with no exponent. So I'm going to, log of 9 is going to stay the same. Plus 5 times log x. Easy enough. Now would be a great time to pause and just review these two examples. Make sure you know what you're doing before we move on, because we're going to move on to a pretty spicy one. Okay. This guy, so we have three variables. We have a fraction bar, we have division happening, we have a root. So pretty spicy. So we're going to separate it now into three terms: log x, log y, log z. Well, the first thing I'm going to look at is the fraction bar, and you can do that every time when there's a fraction bar involved. The first thing you want to do is just split those up. So remember, division inside the log is the same as subtraction of the two logs. What do we have here? We have 3, root 3, y to the fourth. Okay. And then we'll go left to right. So I'm going to start with my first log, and that becomes log x to the fifth plus log z. So I've split up those two terms I was multiplying by. And then let's go ahead and finish that part of it right away. So I'll take that 5 out. I get 5 log x to the nothing this time, right? Plus log z stays the same. And then let's worry about this log y mess. So this looks pretty ugly, right? Here we're going to rely on something from the last lesson. So y to the fourth cube root becomes y to the 4 over 3. So I just rewrote my root as an exponent, and then I'm going to pull that one out. So minus 4/3 log y. Okay. That's it. And then I have log x, log z, and log y. Okay. Like I said, this one's a little bit spicier. Make sure you come back to the video if you get stuck as you're doing these.